talking about depressions and elevation, and I had a question already on that, and I will try to show you or tell you how you should think of it. It's a manual, what you should imagine, sort of a rule. Those are the rules, and this is going to be a huge myocardial wall. Okay, here's endocard, here's epicard. It could be left or right ventricle, doesn't matter. And here is a artery on the top, coronary artery on the top of the, and here is a vein. Oh, sorry, no, this is not good. I want to put it farther. Here's another. Here's a. I'm going to put it from the other side. Doesn't matter. A vein. It doesn't matter because now we're thinking about the wall itself, and of course this is on the epicard. The coronaries are on the top, and they're sending small branches towards inside. Yeah. Oh no. They're sending branches here. Yeah, and like this, and like this. And also we got the veins. So this, and funny thing is, some, watch out, this is very interesting, some of them are actually opened towards the endocard. There's a connection between the arteries, and some of the tiny small branches, they just, like flow like the sewers, they put it back into the end, but most of it runs back to the veins, of course. But the thing is, what you should think of, look at these cells over here. Cells over here at the top, they are fully loaded with oxygen, and because it's just they're getting it from the ventricle. Yeah, this is a left ventricle or right ventricle, what they want. But the cells that are in worst situation, that at the end of the supply chain, are the ones which are just below. They are sub-endocardial over here. Yeah, get it? Because the flow is from over here to here. Yeah. So these are the ones which are not getting the supplies. They're the last ones, and that's why when a vessel is occluded, or there is a blockage and you're getting ischemic, the ischemia always starts, on most of the cases, starts here. Sub-endocardially. Cardially. Okay. So if you stop perfusion in coronaries, the first cells that are impaired and not feeling well are the ones which are actually sub-endocardial, just beneath the endocardium. And that's why, and there's a rule. Anything that happens chemically or whatever, rather sub-endocardially, you will see on ECG, not always, but most, but the depression. But if something happens here, you will rather see elevation. And this is how you should think of these. Because typically, if I'm having ischemia, it will always start rather at the endocardial part. Green is ischemia. And as the occlusion is longer and longer, it grows deeper. And after several minutes, tens of minutes, etc., the necrosis follows. And if it's too long, it depends how long is the occlusion, how long the perfusion is decreased or stopped. If it's going to be stopped for too long, you're going to have transmural infarction. If it stops now and somehow the clot dissolves, you're going to have only non-transmural infarction, okay? But if it's going to go on, the necrosis continues, and as it dies as epicardial, you will have ST elevation, okay? Yeah. So this is the way how it propagates. And you should remember, if something is sub-endocardial only, you should see ST depression. If it's epicardial, you should see ST elevation. Okay? Very simple rule which works. You know what? If I'll give you a question, how would you see not a infarction or ischemia, but only inflammation. If someone has pericarditis, well, you should expect ST elevation as well. Yeah, but in all the leads, remember, this is a trick in all the leads with pericarditis. And look at this. I'm going to go back to what I drew. So over here, ischemia happens sub-endocardially. Over here, sub-endocardial. This is a non-transmural sub-endocardial depression. Over here, it already died. It's here, elevation. Okay? Yeah? Getting back. So, sub-endocardial, epicardial, sub-endocardial depression, epicardial elevation. There are exceptions, but this is the main rule you should remember from today. Okay? This is the way how you look at it. Okay? And look at that. Did I tell you about Prinzmetal's angina? Yeah. Did I tell you it's rather ST elevation? Yeah, because I didn't tell you one more thing. You take this, it's a massive vasospasm. And you should imagine that the vasospasm is everywhere of the coronary arteries, yeah, and in the small branches or whatever. And because it is so massive, the ischemia happens through the whole wall. That's why you see, although it's temporary, but already it hits the epicardium, and that's why you will rather see ST elevation during this ischemic attack. Watch out, it disappears again. But it's the ischemia, the green thing in Prinzmetal's is the whole wall is sort of ischemic suddenly for a few minutes. Then you would rather see ST elevation in the variant, in the Prinzmetal special angina pectoris. Okay? And one more thing, this is an important question. So someone has a retrostellar pain and you think it's really infarction. You're going to get a ECG. What leads you have to definitely check?
V1 and V2.
Okay, and we have no time. I could talk with you about this all the time. No, all the leads. Remember, all the leads. Why? You're looking for ST elevation, and you have to check all the leads because you don't know where the ischemia is or infarction. You don't know, and not there's no one lead that would see the whole heart. Take the leads as a cameras that looking on different parts of your heart. That's we have so many of them. We could have one lead. That's why Apple Watch is not good for MI. That's why it is good only for arrhythmias. Okay? You have to check all the leads and say, oh, there's no ST elevation, so not a single part of the heart has a ST elevation there. Okay? And the analogy, but I already said it, or analogy. If you're looking only for arrhythmia, you can pick any lead you want. And you will see everything about, you can get the information from any lead if you're looking only for arrhythmia, because in all the leads, although they have different shapes, but in all the leads, I mean the graph has a different shape, you will see where now when the atrium contracts and you will see when the ventricles contract, okay? So for arrhythmias, you can pick any lead you want and that's it, yeah? Good. So that's important. And remember, I'll just give you a small hint. That's why you're using ECG. ECG tells you there's MI and sort of tells you, not 100%, where it is. And it's very simple. Remember, if you see this triangle over here, and this is as you can, first one, that's the Einthoven's triangle. And what? So look at that. So basically, and here's the heart, yeah, like this. So you know basically that if you want to see the bottom of the heart, you should check lead 2 and 3. And remember from today, lead 2 and 3, and also AVF, like foot, these are looking down at the bottom of your heart. So if there's going to be ST elevation in these 3 leads, you know that the infarction is over here, which is called inferior wall infarction. Okay? Yeah? Or in Germany and Czech Republic, definitely you can call it diaphragmatic infarction, because this diaphragmatic infarction is the heart lays on the diaphragm. That's where the infarction is located. And also typically this one, because it's through the infarction, it irritates the diaphragm, and that's why it irritates also vegetative systems, typically you're going to have very likely vegetative clinical signs. They're going to vomit or something, okay? They don't feel right. This is a special one. So the inferior wall, and remember, guess if it's going to be anterior wall, like over here, if there's going to be, well, you're going to check V2 and especially V3, V4, V5, V6. So elevation is going to be in these typically. So that's the anterior wall infarction, yeah? So you have to just imagine where are the leads, and that's what they're sort of pointing to, the focal necrosis that is there, yeah? Good? So, thanks for watching, and don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.